Okay, let's go on one by one. So first of all, the basic function of decon is to solubilize the varnish. So you can compare this with solubilizing sugar in your tea, for example. So it completely disappears, and it is not actually doing any damage in terms of creating deposits like that. So decon is doing something similar. It completely dissolves the varnish compounds, and when they are in solution, they are harmless. They do not.
Dalam aset manajemen, kita fokus mengoptimalkan keseimbangan antara kinerja, biaya, dan risiko sepanjang life cycle aset tersebut. Ada 3 hal yang menjadi tantangan kita, yaitu teknologi, bisnis proses, dan kompetensi. Untuk mencapai reliability, sebuah equipment membutuhkan pengenalan telur simptom yang unik, mulai dari sebelum operasi, saat beroperasi, dan saat pemeliharaan. Dan semuanya ini harus dilakukan melalui teknologi yang tepat dan spesifik. Maka dari itu, teknologi merupakan aspek yang harus berkembang selain untuk mencapai reliability, juga untuk meningkatkan produktivitas SDM. Teknologi dan tools yang tepat juga harus diiringi proses bisnis yang terdokumentasi. Proses bisnis sendiri merupakan aktivitas yang terstruktur agar meningkatkan produktivitas suatu organisasi. Contoh proses yang sering kita abaikan itu aset register. Dalam aset register itu ada asset grouping adjustment, sinkronisasi maintenance dengan procurement, standar katalog naming, dan registrasi aset baru. Adanya proses alur kerja asset registration ini dapat sangat membantu dalam monitoring kinerja. Program yang telah direncanakan dalam proses bisnis dan teknologi harus diimplementasikan, tidak hanya didokumentasikan saja. Terus, siapa yang mengimplementasikan? SDM atau personil? Personil yang terlibat haruslah memahami proses tersebut dan juga mampu mengeksekusinya. Inilah salah satu tantangan terbesar dalam mengembangkan suatu perusahaan. Karena proses bisnis dan teknologi dapat mudah direplikasi, sedangkan personil harus dibina. Manajemen aset sendiri membutuhkan waktu untuk berhasil, dan nantinya SDM akan menjadi aset yang sangat berharga. PT 𝗀𝗵𝗶𝘀𝗵 memiliki para ahli dan pengalaman selama 26 tahun dalam menghadapi tantangan-tantangan itu, dan juga berkomitmen untuk terus meningkatkan keandalan aset dengan mengintegrasikan ketiga aspek ini. Untuk itu, kami memiliki partner teknologi dari seluruh dunia yang mampu mengenali telur simptom yang menjadi musuh bagi praktisi reliability. Kami juga menelusuri proses bisnis terbaik untuk mendukung teknologi yang tepat. Dan kami sangat berperan dalam meningkatkan kualitas personil, karena SDM merupakan salah satu aset paling berharga bagi suatu perusahaan. Kami memiliki solusi lengkap yang terintegrasi, komprehensif, digitalisasi, holistik, dan terpercaya untuk membantu Anda dalam mengelola aset dan meningkatkan performa aset Anda. Kami hadir mendukung reliability untuk negeri.
Pengelolaan keandalan aset diharapkan dapat mengarahkan arus proses secara intuitif, sehingga siklus data, informasi, dan keputusan dapat dilakukan secara konsisten dan tepat waktu. Saat ini, kita dapat mengelola keandalan aset untuk seluruh plant hanya dengan satu solusi. Memperkenalkan inovasi terbaru dari 𝗀𝗵𝗶𝘀𝗵. Sekarang, proses owner dapat mengelola solusi keandalan strategis, mengendalikan status proses pengelolaan keandalan, dan mengevaluasi rencana strategi keandalan aset walaupun tidak sedang berada di plant. PLM 2.0 menghubungkan seluruh aset, proses owner, dan informasi pada multi-plant secara terpusat pada waktu yang dibutuhkan.
Si Intan lah. Ya, Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, saya ucapkan kepada Bapak dan Ibu yang telah meluangkan waktunya untuk bisa hadir di acara webinar Tiara series pada siang hari ini. Kebetulan pada siang hari ini yang akan sebagai pembicara merupakan 𝗪𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏 and sharing knowledge on this
you.
session.
Thank you.
Yes, okay. Please let me introduce yourself using bahasa. Oke, baik. Sebelumnya Bapak-Bapak dan Ibu, setelah memperkenalkan Lars, saya akan memperkenalkan juga terkait dengan 𝗏𝗏. 𝗏𝗏 merupakan software dari 𝘊𝗏 sendiri yang sudah di-develop selama kurang lebih 5 tahun, dan sedikit akan saya perkenalkan ke Bapak-Bapak. Oke, sebelumnya kami informasikan pemateri pada webinar siang ini yaitu Mr. 𝗏𝗏. Lars saat ini home base-nya itu berada di Singapura sejak 2013 dan berasal dari Belanda ya. Untuk pengalaman sendiri, Lars di bidang otomotif dan lubricant additive industry. Awal karir sebagai marketing manager di Bosch Workshop Concept di Belgia. Kemudian sebelumnya join di BRB Internasional sebagai sales manager untuk lubricant additive. BRB sendiri merupakan anak perusahaan 𝗏𝗏 𝗏𝗏𝗶𝘀 dan Lars bekerja di divisi lubricant additive selama 10 tahun. Jadi memang sangat berpengalaman ya khususnya di lubricant. Kemudian selama berkarir, Lars banyak pengalaman di lubricant chemistry, tribologi, dan international business. Kemudian kondisinya saat ini, pengalaman-pengalaman yang sangat banyak itu diaplikasikan di perusahaan Fluitec internasional yang home base-nya itu di Singapura sebagai General Manager Asia Pasifik. Nah, terkait tema atau judul dari webinar pada siang hari ini, yaitu Solvancer, a risk-free enhancement to extend an oil life, yaitu terkait salah satu Fluitec solution untuk mengatasi isu varnish dan oil degradation terkait dengan antioksidan depletion ya. Harapannya adalah kami sebagai penyelenggara itu bisa sharing knowledge bagaimana menjaga agar oil bisa clean, pure, dan free dari varnish. Karena isu varnish sendiri sangat berpengaruh terhadap umur oil dan salah satunya juga untuk menjaga reliability dari aset. Selain itu, harapannya juga kita bisa mengextend lifetime dari oil itu sendiri, kemudian bisa cost saving atau penghematan, dan environmental juga akan sangat berpengaruh. Untuk itu kemudian kurang lebih webinar ini akan dilakukan selama 1 jam dan diharapkan pertanyaannya itu dari Bapak-Bapak atau Ibu bisa dituliskan di kolom Q&A yang ada di bagian bawah dan nantinya dikirimkan ke panelis. Untuk nantinya saya sebagai moderator akan menginformasikan kepada Lars dan akan dijawab secara live. Oke, sebelumnya saya izin screen sharing terkait dengan software 𝗏𝗏. 𝗏𝗏 ini merupakan singkatannya, baseline for overall life cycle strategi, yang mana ini sifatnya adalah web based untuk bisa mengetahui kondisi dari aset yang tentunya dijaga oleh bapak-bapak sekalian yang ada di pabrik atau di site. Salah satu fiturnya adalah terkait dengan dashboard yang mana kita bisa mengetahui kondisi aset wellness-nya, terus kemudian ini secara overall, untuk kemudian kita bisa melihat apakah dari masing-masing teknologi yang digunakan, baik misalnya vibration, oil analysis, maupun juga infrared contohnya, status dari masing-masing teknologi, apakah statusnya warning, danger, atau normal ya. Untuk detailnya, tentunya di feature Bolden sendiri kita bisa melihat kondisi dari equipment yang kita pilih. Di sini contohnya ada equipmentnya main oil tank. Secara overall ingin mengetahui secara status apakah merah, kuning, hijau, warning atau danger. Kemudian teknologi yang digunakan untuk memonitor aset tersebut. Di sini contohnya adalah oil analysis. Untuk kemudian dari maintenance strategi, kemudian dari failure mode effect analysis, kita bisa inputkan juga apa-apa yang perlu dilakukan, apakah dari mulai functional failure-nya, kemudian failure effect-nya, dan failure cost-nya, untuk membantu kita menentukan maintenance strategi yang paling tepat ya. Selain itu, spesifik terkait dengan equipment-nya, itu juga kita bisa mengetahui secara web base yang mana dengan menunjangnya industri 4.0 ya, yang sifatnya software ini web base, itu bisa mengetahui kondisi dari teknologi status, kemudian measurement point, misalnya di sini ada viscosity, acid number, kemudian roller maupun MPC atau varnish. Kemudian dari secara overall teknologi status di sini contohnya ini merupakan account demo ya, statusnya kuning. Kita bisa melihat examination-nya apakah kita menggunakan metode FDCAR, finding, diagnosa, analisis, conclusion, dan recommendation, untuk bisa direview oleh analis apakah rekomendasi yang sudah diberikan oleh teknologi spesialis itu sesuai dengan kondisi yang ada di equipment di masing-masing site atau di pabriknya. Untuk kemudian bisa kita lihat juga untuk evidence secara detail maupun trending dengan cara mengupload kemudian mendownload report yang lebih spesifik untuk nantinya apabila equipment tersebut itu terdiri dari berbagai macam teknologi, itu bisa ditentukan secara aset wellness-nya statusnya hijau atau kuning atau bahkan merah, untuk kita review kembali statusnya dan finding, diagnosa, analisis, conclusion, dan rekomendasinya secara level aset apakah memang sudah sesuai atau tidak. Nah, itu sedikit gambaran tentang software Bolden yang Tiara sendiri develop. Mudah-mudahan secara singkat ini bisa meng-capture dan memberi tambahan informasi apakah bisa diterapkan di site atau di pabrik yang Bapak miliki sekarang ini. Baik, dari saya cukup. Oke, thank you, Lars. So I already finished to sharing about our Tiara software. Please proceed and continue to give us new knowledge on this session of webinar.
Thank you very much, Ari.
Yep. Yes.
Thank you. Can I share my screen and I will start the presentation?
Okay, I already stopped my share screen.
Okay, great. Okay, can you see the correct screen now?
I can see the full screen of PowerPoint. Okay.
Okay, great. Okay, All right, so then let's get started. First of all, thank you everybody for joining this webinar today. I hope it is useful for you and that you will learn something from this today. Feel free to ask any questions if we have time in the end, or contact PT Tiara for any questions that you have after the webinar. We will be more than happy to address them and to answer your questions. So the topic for today is Solvancer. Solvancer is best described as a risk-free enhancement to extend an oil's life. It is a addition to the oil as an in-service addition. That's what it's meant to be. Now for today, I have a few topics lined up. First of all, I would like to give you a brief introduction to Fluitec. Then we will try to teach you a little bit about selecting the right varnish control strategy. This means we also need to go a little bit into the background of varnish. Then I'll introduce you to ΔECON, which is our main product under the Solvancer range. I'll explain a bit about the industry support that we have for this product and its short-term and long-term effects. If we still have time, we will also discuss some case studies, but it's a lot of topics to discuss for today. So let's get in it. First of all, a little explanation about Fluitec. Our name says it already. We're a company that's in the fluid technology business. And the words below our logo here are a little bit summarizing our mission. We have a holistic approach. We like to measure, we like to consult, and we like to treat to make sure that we have a full scope that we can deliver to the customer. Our office are based in the Netherlands. Our corporate seat, I should say, is based in the Netherlands. That's our HQ. However, our main operations and R&D center are in New Jersey in the USA, which is also a major global logistical hub. For Asia, we are in another major logistical hub, which is Singapore. That's our Asian headquarters. That's where I am based. And from there, we deliver to the region and work locally with agents such as PT Tiara in Indonesia. We have a local joint venture also with some production capacity in Melbourne, Australia. So we're nicely suited to tailor to the market. So what is it that we do? Well, there are some aspects to this. First of all, the measuring aspect means that our roots are in condition monitoring. We have started out as the inventor of the ruler view test. So this is our own invention and patented by Fluitec. We have then also co-developed the MVC, which is one of the major standards today by OEMs and oil suppliers as a varnish potential condition monitoring method, I should say. So these are our two essential parameters and are now recommended by most OEMs as a standard oil analysis slate. So that's the measuring part. But after we measure that there is a problem, we would also like to do something about it. So we also develop products that are able to remove bad products from the oil, that are able to remove aging products. And we like to compare this with removing cholesterol from the body. We move bad products from the system so that it doesn't become an issue. We've also developed long-lasting lubricants. Fill for Life strategy aims to make the lubricants last as long as possible. So we have our own Infinity brand of lubricants, which have a 10-year warranty against deposit control, against deposit formation, I should say. We can also refortify in-service products, and that's actually the major part that we will talk about today. So we have developed enhancements to the oil, which companies can use in service as an enhancement to prevent varnish, but also to refortify the oil, to re-additize it, and to make the whole oil stronger. So it all starts with varnish. Varnish means a lot of things, actually. It's just one word, but it comes from oil degradation. And because it comes from the oil degradation, it is actually consisting of various chemistries, and in different operating conditions, it can show itself in different ways. So varnish is just one word, but it comes in many different forms. And as you can see from the wheel on the left, it also is prevalent in many different industries around the world. Actually, everything that uses an oil, especially in industrial oil, will have varnish formation in some form or another. So it's a very widespread issue. And we have two main solutions for that. We have an addition to an enhancement, I should say, to the oil, known as Solvancer, which is the main topic for today. But we also have specialized filtration known as 𝗏𝗏 ESP to remove varnish from the oil, because varnish cannot be removed by a normal depth media filtration. So our total product line is consisting of 4 main products. For us, it starts with knowledge sharing, because we want to educate the market. We want to let people know what varnish is, and we want to let people know how they can be more sustainable, more efficient, extend the life of their oil, and so on. So we have developed a platform for that, which is called Fluid Learning, where we give webinars such as this, and we publish it to the market and to people who are interested in that. So do take a look at Fluid Learning as well if you get a chance. Then we go into condition monitoring, as briefly discussed already, our ruler and MPC. Contamination control stands for the specialized filtration systems that we have. And for today, the main topic is the Solvancer product. Our customers are spread over various industries, but they consist of most major petrochemical and oil producers, but also the OEMs such as Siemens Energy, air separation companies such as 𝗀𝗏𝗃𝗀𝗃, shipping lines such as Maersk, and of course the major oil companies, 𝗂𝗏𝗄𝗏 and Shell, are our customers as well. So we span across many different industry sectors and geographies. A very nice core of what we do is in sustainability. And of course, this is nowadays a very hot topic. By applying our products, we can quantify a certain amount of CO2 that is being reduced, either by increasing the efficiency or reducing the amount of oil that's being used, and therefore reducing the amount of oil that needs to be produced. So here are some figures that we have put together to quantify this, but the main message is that using our products will significantly increase the sustainability of any industrial production plant. So let's have a look at what it would be the right varnish control technology. So here you see an example of a plant with varying production sites, which all use industrial oils, and they will all have varnish being formed in one way or the other. So first of all, we need to look at what is oil breakdown. Specifically in this case, turbine oils, RNO. The breakdown means the chemical or physical change of the fluid, which will inhibit its performance. So it will have a negative impact on its performance. This often results in the formation of varnish, which is the sticky layer that forms on metal surfaces. What do we mean by that exactly? So varnish is basically a deposit that's on the metal, but it's made up of various chemistries. And this depends on the operating conditions, the chemistry of the fluid, and contamination that might be happening in the lubricant. But what varnish is, it's an oil-derived deposit. So it comes from, usually it comes from within the oil itself, and it's a chemical reaction. And for example, depleted antioxidant additives can start to form varnish. And because it's an oil-derived deposit, it comprises of soft and soluble organic compounds. Because they are soft and soluble means that they pass through depth media filtration, they pass through your filter membranes, and they are not able to be filtered out by normal filtration. And this is the reason why we need to look for specialized methods to combat this issue and to help prevent varnish from forming. That's the background of this. Now, this issue has worsened over time because the evolution of rotating equipment. Plants have run hotter, equipment has become smaller. You can here see the example of the old car and the Tesla. These require completely different equipment, but also completely different lubricants, of course. And this also means we need to treat those lubricants differently than, let's say, 20 years ago. Some examples, you can think about changing operating conditions in power plant, higher base load, cycling, on and off of turbines in some case when there's a base load issue. So that all adds stress onto the oil. Lubricants today may also have multiple purposes, and the formulations of lubricants have changed to cope with this. So new formulations of lubricants have generally resulted in higher performing oils, but also need more care. They need to be monitored and maintained differently, and they need to have some extra love and care to work properly and to prevent deposit buildup in your system. If we look at the evolution of lubricants and the way that they are being operated, we see that the stress on oils has increased, generally speaking, by 400%. This does not come from us, but this is from the OEMs. They have concluded this. Of course, you can imagine the thermal stresses on the oil and so on are greatly increasing the way it degrades and decomposes. And this all adds to the varnish issues that we see in the market and reducing of lifetime of the oil and also the equipment. So this is something we want to deal with. So the signs of trouble first started showing in 2002 when the reports of deposits are discussed in user groups, and this then evolved into the OEM consensus that we have today, that oil-related failures are causing 40% of mechanical issues, and more importantly, these are often preventable. So I'll repeat that. Oil-related failures today are causing 40% of mechanical issues and could often have been prevented. So if you have a good oil analysis program, a good condition monitoring program, and you take preventive action, you can potentially prevent 40% of breakdowns that happen. This is an enormous amount of money that potentially can be saved in the industry, and it is an enormous amount of environmental damage that we can potentially prevent from happening. Of course, the costs of poorly maintained turbines, compressors, or rotary equipment can go up to the hundreds of millions. And this is not even taking into account the hydraulic systems that we also see having a lot of varnish issues nowadays. So the new challenges that we see in the turbines are, for example, more sensitive controls, higher thermal stresses, the duty cycles have changed completely, and oil formulations have changed, but also have multiple functions now. This leads to varnish, and varnish can have varied appearances and definitions. So here you can see it can come as a spongy or a sticky substance, even a powder. Sometimes it's burnt, sometimes it's very gooey. Sometimes it will be a layer that you almost cannot remove from the metal. So it comes in many different forms, and this is depending on the chemistry and on what is causing the varnish. It can also come in various colors, as you can see here, which is also again related to the chemistry. And very often when there is over time a longer period of varnish formation, your oil in your system internals or your oil tank will look something like this. You will have this orangey brownish layer that is on the side of the tanks, which is literally a varnish layer, which is a sticky and very tough layer to remove. Now, this is actually contributing to contamination in your system and in your oil. And if you do not remove this, it will make the oil degrade faster. So if you put new oil in a contaminated oil tank that has varnish issues, you will degrade your new oil much faster. When varnish appears on machine internals such as bearing pads, it can create hotspots. It's self-insulating. It creates more thermal stress on both the bearing pads, but also on the oil. Of course, you will create hotspots in the oil. And when you create hotspots in the oil, it leads to even faster degradation of the oil, which leads to more deposits being formed, and so on. You go into a auto-accelerating cycle, and the problem only gets worse from there on. So you would like to act before this happens, of course. You also see gear coating coated with varnish in some cases, which of course can also be an issue for efficiency and hotspots that would be generated on gears. And very often we also see heaters and coolers that do not perform well anymore when they are insulated with varnish, because varnish is an insulator. So your heat exchanger will of course be reduced in efficiency when it has a varnish layer. This can significantly increase the startup times of plants and can decrease the overall efficiency of the production. And this is becoming a major issue nowadays in the industries. One of the biggest problems we see specifically in compressors and hydraulic systems is valve sticking. So valve sticking, for example, here you see a servo valve, is when the varnish layer is becoming too thick and sticky, and it actually prevents the valve from moving properly. And then you get either a decrease of efficiency of your machine, but in many cases it will also stop working. You will get a breakdown and you need to go into a shutdown to do some maintenance. Here you can see an example of varnished varnished valve, servo valve actuator, which is here broken down. Also on bearing pads and bearing housings, actually, you can see that the varnish layers can lead to hotspots, insulating the metal, and will create more varnish on that spot because of that. And this is then a problem that will increase the bearing temperatures, because this will generate more heat. And this is clearly seen, of course, in condition monitoring of the plant. And then a shutdown is needed and something needs to be done. Here you can see varnish impacting higher temperature. Always you will see a sawtooth pattern when it goes up, because it will not go up in a straight line with bearing temperatures. So this is very typical for a varnish induced temperature increase. So when you see the sawtooth pattern, it's most likely a varnish issue. Here you can see correlation between vibration and bearing temperature increases as well. You can see that the bearing vibration has increased significantly, and bearing temperatures are going up. So you can also see here that this is in a sawtooth pattern, and we see this very common. We see a very common origin for this is varnish. Now the cost of all this, if we look at what in big maintenance overhauls of large equipment, we see what it can cost to change all the varnish affected materials. So for example, a bearing pad costs 250K. You can see the bearing pads are even more expensive for truss bearings and so on. So you can calculate how much money is being left on the table by the industry by letting this happen and just waiting for something to break, or maybe not being aware of a better way of doing things. And this actually is costing a lot of money. Okay, so that is the problem. We have discussed this, and this is a problem that is growing. Now, luckily, we can also come with a solution. Literally, in this case, we have a product. I will focus today mainly on our product that is called 𝗃𝗀, which uses our Solvancer technology. Solvancer is a patent pending technology, and it is basically a solubility enhancer. And by increasing the oil's solubility, you prevent it from forming deposits. So it keeps the varnish compounds in solution in the oil and prevents it from attaching to the metal of your system. And by doing this, it actually prevents deposits from being formed. But when the oil passes by existing varnish, it will also absorb this varnish. So it can be used in a preventive and a reactive manner. So today we focus on 𝗃𝗀, but this is the Solvancer ecosystem, as we like to call it. We have a couple of products derived from Solvancer, and the main functions of Solvancer are system decontamination, which is a more economical and sustainable way of cleaning lube systems in between oil changes. That means that you can dose the system dose this product into the system before an oil change, and because of its solubility function, it cleans up the system internals, and then when you change the oil, you do not have to do a chemical flush anymore. So you can completely forget about chemical flushing, which is much more environmentally friendly. It reduces your shutdown time significantly, and it reduces the cost of the shutdown as well. and it's perfectly safe to be kept in the system for longer periods of time. There's no concern on that. It can also be used for what we like to call troubleshooting, which is the ability to immediately solve critical issues, meaning that if you have any of the issues we have just discussed, such as high bearing temperature, sticking valves, and it is likely caused by varnish, you can dose in a certain amount of 𝗃on into your oil, and this will remove the varnish from the valves or from the bearings, immediately reducing the bearing temperature and mitigating the issue. So that will prevent a shutdown. And this is something that we have been doing worldwide extensively, also with companies, for example, like ExxonMobil and their refineries, when they were running at max capacity and did not want to have a shutdown. They ordered 𝗃on from us when they had increased bearing temperatures to remove the varnish and to keep on producing. So you can imagine how much money they can save that way. Life extension is possible when we look at the bottom three products. Sorry, bottom three, I should say. 𝗃on AO, which means for solubility enhancement combined with an additive package. Same goes for 𝗃on AW, but this is a different additive package, which is suitable for hydraulic systems, for example. So by adding these together, you can actually extend the life of the oil when your additives are depleting, and you get the benefits of varnish mitigation together with life extension of the oil. So you can see that these are prevalent in many different markets. And let's look a little bit more into 𝗃on for a start. So you can use it in for decontamination and for deposit control. That's what it stands for. So it can be used in between fluid changes. It can be used to correct mechanical issues, as I just mentioned. It can be used as a preventive measure. If you think your system is going to generate deposits, you put in a little bit of 𝗃on to prevent this from happening. And it's perfectly safe, risk-free, and it gives you a long-term protection against deposits, sludge, and varnish. So you can leave it in the system throughout the life cycle of your oil or your system. You do not need to worry about changing it. You do not need to worry about leaving 𝗃on in your system for a long time. That is because 𝗃on is a blend of specialized group 5 chemistries. So this means it has there's no concerns on compatibility because it also has superior seal compatibility. It is very kind to seals. It has excellent oxidation stability and deposit control characteristics. This means mainly that it does not degrade itself when it is in the oil over a longer period of time. It does not form any deposit as compared to other additives. And it has no negative impact on the oil's performance. So all the functions the oil needs to perform, cooling, lubricating, all of that are perfectly kept as per normal when you add 𝗃on. So think of, for example, air release, foaming, the emulsibility, viscosity, all these aspects will be within spec with 𝗃on. It does not have any active additive components. The 𝗃on product as itself, the core product, is a solubility enhancement that does not have reactive chemistry. So it does not react with any other additives in your system. This means it does not create any issues and it does not create any compatibility issues. So it's very safe to use and very efficient. Simple and risk-free, that's the key. It can be poured in the system while it's in operation. The typical treat rate is 3 to 5%. There's no pre-mixing needed, no offline pre-mixing of oil. It can all be dosed during operation in a very simple way. It is fully compatible with most hydraulics and industrial, if not all industrial fluids in the market today, at least those that are formulated with group 1 to 4 base stocks. And this gives it, of course, a very wide range of applications within the industrial market space. So earlier on, we talked mostly about rotary equipment, turbines, and compressors, but also think about hydraulic systems, for example, plastic injection molding, hydraulic presses, a lot of applications in that world, metalworking as well, that you can potentially have a lot of benefits by using 𝗃on to prevent your scrap rates. So how does ΔECON work? It works by literally dissolving the oil degradation deposits. So it increases the oil ability to solubilize, and by doing that, it will molecule by molecule dissolve the varnish from your system internals, as is depicted here in this picture. And when it does that, it cleans up your system. So it keeps the varnish compounds solubilized inside the oil. It keeps them completely harmless. So it does not do any harm to your filters or to your system internals anymore. It keeps it in solution, and therefore it is no longer able to do any harm. And your system will be clean. So when you do an oil change or shutdown, you do not need to do extensive cleaning or chemical flushing. So you reduce the cost significantly. The industry is also supporting us on that area. We have here an official recommendation by Siemens, which has endorsed that compatibility and effectiveness of ΔECON may be beneficial to add to stop or reverse the varnish effect. These kind of statements from a company like Siemens Energy are very significant. They hold a lot of weight. When they put out a letter like this, they have done a lot of validation testing by themselves before they stick their neck out like this. So this is something that we are quite proud of, and is really a good performance validator of our product. Also, together with Solar Turbines, they have used our Solvancer technology in a lot of solar turbine packages to date. I believe it's actually much more now than 37. This slide here still says 37, but I think by now it's probably more than 70. And they have very good results worldwide with this. And they also recommend ΔECON to use in the product. Also, one of the major oil supplier, if not the major oil supplier, ExxonMobil, has engaged in a partnership with Fluitec, and they do this in a co-branding arrangement, meaning they buy the core product from us, which is a very similar product to ΔECON, or it is actually as good as ΔECON product, and they sell this under their own brand name as Mobil Solvancer. So you can imagine when Mobil does this, it means that they have run a lot of tests. They have done extensive compatibility testing in all the general oils that are available in the market, not just Mobil, but also from their competitors, because they also recommend Mobil Solvancer as Mobil Surf for their customers. And they use it in the same way that we use our Solvancer product. So this is a very good performance endorsement by the major oil supplier. What is the main benefit of ΔECON is that it has an immediate impact on varnish potential and MPC values. You can see that the MPC will go down usually within 72 hours to 1 week after dosing in the ΔECON. You will see significant drops in MPC, and this, of course, is very good for your varnish potential. Here you can see a test also demonstrating this, where we have a new oil that has been stressed in the TOPP test, the turbine oil performance prediction. And this is an accelerated oxidation test. We use an accelerator coil in an oil bath to increase oxidation. So 6 weeks stands here roughly for a lifetime of 6 years. And you'll see that the antioxidants go down a bit, but especially the MPC goes to critical level at 64. And when we do the same test on the oil, but at Solvancer, we see that the MPC doesn't go above 6. So significant improvement in varnish potential. Here you can see the visual results of this. Same oil without Solvancer on the left, same oil with Solvancer on the right. So significant improvements on MPC and the visual appearance of the oil. And what is also a key benefit of ΔECON and Solvancer in general is that it does not form deposits when it degrades. So even after antioxidants have been consumed, Solvancer still works to prevent the creation of deposit. Normally, what will happen when antioxidants are depleted, you will get, it's like you lose the protection layer of your oil. This means that you get a lot of deposits that are being formed, an increase in acid number and so on. This will all accelerate the amount of deposit and varnish being formed. But even in those circumstances, ΔECON provides an extra layer of protection when the antioxidants deplete to prevent the build-up of deposits. So it offers you additional protection even when the other aspects of the oils have failed. Here we can see the TOPP test on an in-service oil, where also visually and on the MPC test, you can see significant improvements when we add only 3% of ΔECON. So this would be related to a preventive way of using ΔECON, where you think an oil is going to perform really bad in varnish potential. You add in a little bit of ΔECON, and you can see here the effects that this has on the oil. Extremely low MPC values compared to the neat oil, and also especially if you look at the beaker and accelerator coil, which was completely varnished in the original test and has no deposits in the test where we use 3% of ΔECON. We can also compare test results with real-world experience, in the field experience, I should say. So you can see on the left slide here the MPC results of TOPP testing. As mentioned before, after 18 weeks, there was no deposits being formed, so very good results. But we also see on the right side the real-world situation. This is just one, but we have many cases, of course, in an N2 feed compressor where the neat oil was actually giving almost critical MPC levels after 3 years. The same oil with 5% of ΔECON had almost no MPC increase after the same period in the same compressor after 3 years. So also in the field, we see very good results with ΔECON. All right, so that summarizes a bit on our ΔECON product. I would also like to talk a bit today on ΔECON AW, hydraulic product with Solvancer technology as a base for its performance. This product to us is a paradigm shift in hydraulic fluid management, because it completely changes the way that operators can deal with their hydraulic fluids. This is because we see a lot of failures nowadays in hydraulic fluids. It's a bit similar to the turbine oils, but it's a bit more complex because the formulations are more complex as well. We see increased thermal stress because of higher efficiency requirements and smaller oil sums, and of course environmental concerns means that everything needs to be smaller but hotter, and this has an effect on the oil. This also means that lower leakage rates are allowed because of environmental concerns. All of this means that you have extreme oxidative and thermal stress on the oil, meaning a lot of heat, and this always increases a lot of oxidation. That's why we see the #1 failure mode for most of the hydraulics is oxidation at this moment, directly or indirectly. So we want to combat this because the cost of fluid failure in manufacturing is enormous. So here you can see a servo valve sticking on the right side, and this will also impact not only valves, but varnish also impacts deposits on pumps, through deposits on pumps and the system. This all increases the scrap rate of materials, it decreases the production efficiency, and it overall increases the cost of production. And of course, also, this is very bad for the environment. A lot of oil is being prematurely discarded. A lot of components are being replaced prematurely. So these are the impacts of varnish in the manufacturing world. So what can we see that is really increasing the cost? Of course, increased valve pump and repair cost, overall shorter machine life, and of course, overall shorter oil life. This is increasing production costs around the world. And this can be, for example, due to varnish coating, and also as discussed before, varnish coating on heat exchangers can decrease the efficiency. So what can we do to prevent this? Well, we can provide ΔECON AW, for example. Also, normal ΔECON will work perfectly in these systems to remove the varnish. But when you add ΔECON-AW, you not only remove the varnish and decontaminate the system, but you also upgrade the antioxidant system and restore the anti-wear capacity of the oil. So you increase the amount of antioxidants and anti-wear additives in the oil. So you get basically a decontamination and varnish removal and a boost of the additive system, which provides enormous life extension to the oil. So the oil will last much longer, but it will also run cleaner. It will run more efficiently. You have lower leakage rates, less breakdown, less replacement of parts. And you can see this clearly when it comes to increasing manufacturing profitability. By fortifying this oil, by extending its life, but mainly also by making your equipment run better and more smoothly, you can lower the hydraulic cost significantly. So you significantly increase the oil life. You will have 60% savings over an oil change by increasing, for example, RPVOT value by 3-fold and reducing scar diameter in the 4-ball welding test significantly as well by as much as 50%. We've also seen that it helps to control foaming, which also increases efficiency and reduces leakage rates and so on. So you get many benefits on your manufacturing side here, which will increase profitability and increase sustainability of your production. And again, this can all be done in service through adding ΔECON-AW into the system while the plant is operating or in service. So we also have for today, as the last topic, in the essence of time, a few case studies that we can share with you from the field to show how it works in real-world conditions. So we have some experience with pipelines from major oil supplier as well. So in this case, the varnish has helped to increase the efficiency here. But major applications for us are compressors in a refinery, for example. So here you have a cracked gas compressor. What happened here was they were experiencing high bearing temperatures in a steam-driven compressor. So the MPC was in this case actually elevated, but not so critical yet. And the antioxidants were still at an acceptable level, were still relatively high at 69% according to the ruler testing. However, there were some mechanical issues that were being experienced, high bearing temperatures, and an observable impact on the shaft rotor position, meaning the vibration of the shaft, which correlated with the temperature spikes. And again, you see the sawtooth pattern. This means that it's likely there is varnish. So in this case, the customer decided after our advice, they wanted to add ΔECON into the system to see if this would have a positive effect. So even though the MPC was not critical, it was still elevated. So it went back to 1 after 1 day, from 22 to 1, and stabilized at around 4. But more drastically, we could see after we added ΔECON, we have an immediate reduction in bearing temperature. So of course, the overall temperature, the average temperature here was reduced significantly, and we have prevented the sawtooth pattern from occurring where you have temperature spikes in your system every time there is a varnish layer occurring. So in this case, over a 2-year period was measured, and for 18 months, the bearing temperatures have remained very stable and the MPC has remained low by adding a bit of ΔECON into the oil. So very good results. And we have seen many cases like this in refineries, also with ExxonMobil. So the refinery does not have to bring down a unit because of the high bearing temperatures, because that's normally in the past the only solutions that they had. Shut down, break everything open, clean it, and go back to normal. But now they did not have to do that. So they could prevent enormous costs, of course. Also, ΔECON has provided excellent deposit control, preventing formation of varnish. And this continues, of course, throughout the life cycle of the oil. So it will prevent deposits from building up anywhere in the system. And we can confirm this, of course, with the mpc tests that has shown a lower varnish potential of the fluid, actually to very low levels, to what you would expect from a new oil. So overall, very good results on this unit for this plant. And as a user, you have multiple benefits, of course, to this situation. With solar turbines, we have many good experiences, but this is just one snapshot of one customer that was using 10 solar turbine packages in the US. Was experiencing high MPC levels, and in order to prevent this from becoming an issue, discussed with us and added a certain percentage of decon into all these solar turbine packages. And as you can see, the MPC were all returned to normal, to below 10, in some cases even below 5. So the oil is running clean, and this means that your system is running clean as well, and therefore increases your efficiency and especially your reliability as well. Here we see a very interesting case. It's a bit of a specialistic application, but for hydrogen compressor, which is using a very expensive PAO at $75 a gallon, always experiencing high varnish levels, which actually led to annual oil changes of this very expensive oil, and weekly, think about that for a while, weekly filter changes. So that was really a lot. Decon was added to the fluid at 5% when the fluid was 10 months of age. And what we see was an immediate effect here on the MPC. And this had immediate effect on their filter changes. So the filter changes went from every week to 21 months and still counting. So the impact on the oil conditions here was significant, and you can imagine how much money they saved alone on filters. Well, actually, we also calculated this. So the filter savings was 5.5K during the period of 21 months that we measured at this customer. But the oil savings, being a very expensive PAO, was even more significant. So just for this minor correction, adding in a little bit of decon, the total savings amounted to $51,000. And this is very common that we see that with this kind of correction, and by adding decon, we can achieve massive savings in terms of maintenance and operations at a plant. And of course, we have not counted here that there has been no maintenance, no breakdowns, or no operational issues which they previously had due to varnish. So if you count those, the savings are even much higher than this. Case study here on a heat exchanger, where we see that the varnish layer was preventing the heat exchanger from acting efficiently because of the insulating layer. And during the outage, you can see here the difference between the before and after effect of decon. In the nitrogen plant here for case study number 5, the machine had a major overhaul due to varnish. In this case, we added 5% of decon, and the monitoring signals were stabilized. As you can see here on the top of your screen, you can see oil temperatures in the pink graph being erratic. You can see back pressures of filters being erratic as well due to filter plugging. Every red arrow on the yellow graph is showing back pressure decrease or increase due to filter plugging. And this led to complete machine overall. Now, after adding decon, you can see the difference immediately. Everything changed and stabilized. Lube oil back pressures were returned back to normal, and vibration decreased, and so on. And of course, no more filter change as regular as before. So decon helped to stabilize this whole plant operation. Again, significant benefits from a relatively minor correction. So the final case study that I have for today is here in the Gulf of Mexico, where we had a solar turbine tower 60. This customer was concerned because it's a high salinic environment, a lot of moisture in the air, and high temperature. So these are all aspects which are very bad for the oil. They all increase oxidation, they all increase degradation. So this customer thought, let's just be ahead of the curve, very smart thinking, and let's add 5% of decon to this lubricant to provide a long-term protection from varnish so that I can operate here in this challenging environment carefree, and I can sleep soundly at night. That's what they did, and we had some very good results. MPC went from 28 to below 1, so that you cannot even achieve that with a new oil. And up to date, they are running their equipment without any breakdowns, which is an enormous improvement to what they had before when they had regular issues with their turbine. And for an offshore company that always has a challenge to provide to fly in spares on time, and that has significant cost when something breaks down, this is an enormous benefit and of enormous value to them. And we have a lot more of these cases in the offshore world as well. So ΔECON, in summary, it's a cost-effective and highly scalable solution to varnish, meaning it can be used in many different applications, from a small plastic injection molding machine to a 60,000 liter power generating turbine. So wide range of scalability and application. It will lower MPC values by dissolving the deposits from the internal of your system. It will lower MPC values by keeping varnish solubilized, and with that it also dissolves deposits from the internals of your system, thus cleaning your system. In the long term, it will protect from forming deposits and varnish, and will add an extra layer of protection if the additives of your oil fail. And it will provide protection for as long as the oil is in service. No concerns on compatibility. It's completely risk-free, and will make you sleep soundly at night. So that's the end of my presentation for today. I hope the information was useful. We started a bit late, so we're still a little bit within the time frame. I'm curious to hear if there are any questions, and we'll be happy to answer that.
Okay, Lars, thank you very much for your great presentation on this session. So there are a lot of questions in a Q&A chat box. Good. But some question I already answered, but I can combine some question also. So there are several participants have a quite similar question. So during this Q&A, I will inform you the question one by one, so you can answer it one by one too. So first question: this customer have a air compressor that have changes of lubricant to become gel. So he asking what is the possibility for that cause, because the type of compressor is using air that combine directly with the oil. So you can answer that.
So sorry, what was exactly the problem? The oil form gel?
Yes, become gel.
Before an oil change or after an oil change? Because you mentioned something about oil change.
Not confirm about that, but during operation, from oil become gel.
Okay, so this can have multiple issues. The most common, what we see here, is that there would be water ingression that increases the acidity of the oil, and this compound can lead to oil becoming gel. It can also be runaway oxidation that leads to increase of viscosity. But in order to really look at this question thoroughly, I would need to have a little bit more information, and possibly also some oil reports that have been taken over time, and some pictures, because it's not an easy question to answer like that. We need to have a bit more information and research, because potentially there's a lot of things that can lead to oil gelling. So we need to do a little bit more of a deep dive into that.
Okay.
Which we would be happy to do, of course.
Sure. Oke, silakan nanti Bapak ketika misalnya ada oil analysis report bisa kirim ke kami untuk nanti diteruskan ke Lars, so he can analyze within that report ya. So we can continue to number second question about how to prevent oil varnish at equipment and how to detect varnish in oil during equipment operated?
Very good question. So the main equipment that we have for measuring the varnish potential are the MPC tests. The MPC is ASTM D7843, which is available at most of the major laboratories, and our agents in various regions are also performing this test. So this is the first test that you want to do to look for the varnish potential in the oil. If this MPC test is too high, and this means that you have high varnish potential of the oil, we can look at the proper solution for your specific application, oil type, and operation conditions. Then we can give you a recommendation whether you should use ΔECON or ΔECON AW, or maybe even a filtration system. And then we can give you a very specific advice on that. But the first step would be, I would recommend to do an MPC test on an oil sample.
Okay, then. Thanks. So we can continue to the third question. This question I combining several questions. So when we use Solvancer or ΔECON, first thing where the varnish will be come and will be where for the carryover, yeah. And then what the effect of the ΔECON, is it will affect in like oil properties, some example like water content, or if there is some water content issue, it will be effective if we use ΔECON.
So okay, let's go on one by one. So first of all, the basic function of ΔECON is to solubilize the varnish. So you can compare this with solubilizing sugar in your tea, for example. So it completely disappears, and it is not actually doing any damage in terms of creating deposits like that. So ΔECON is doing something similar. It completely dissolves the varnish compounds, and when they are in solution, they are harmless. They do not pose a threat to your filters. They do not pose a threat to your machine internals, and ΔECON will keep them in solution for as long as the oil is in service. So that's what we've also shown with the accelerated testing for 18 weeks, which simulates an 18-year procedure. And we have customers that have used the product for a number of years already, and it will keep the varnish in solution, so it will not form any harm. That's how ΔECON works. That's why it's risk-free, and that's why it's supported also by ExxonMobil, for example. On the question of water content, if you have water content, there's not much that ΔECON will do to help. It will add protection by preventing deposits from the degradation that is occurring because of the reaction with the water. So you will have some protection, but it will not solve the core issue. So if you have an issue with water, you would need to look at the water ingression, where is it coming from, solve that, and you need to look at water removal, vacuum hydration, and there are various technologies available in the market to do water removal.
Okay, then very clear.
Okay.
And then we can move to another question. So when we do the Solvancer or ΔECON into the operated equipment, such as like a turbine engine or compressor, and then when that equipment overhaul, will be detected as a foreign chemical?
No, because it's inactive chemistry. So it is not a reactive chemistry. So it's actually inert chemistry. So it will not be detected as a foreign chemical.
Okay. So it not be detected as foreign chemical.
No, not if you use ΔECON, for example. Of course, if you use AW or AO, that has antioxidants and anti-wear inside, that would be detectable. Yeah.
Okay, then. So this is still related with a ΔECON AW. So the question is, how does ΔECON AW work to help anti-wear additive work?
Yeah, so it has two functions. It reduces the deposit generation, so it reduces the varnish potential of the oil at PC levels. It has anti-wear additives inside, very high quality anti-wear additives, which are kept in solution, of course, also by the ΔECON. So ΔECON also helps to increase the compatibility with these anti-wear additives when it's being dosed into the oil. But we would also, for ΔECON-𝗍𝗶, still recommend to do a compatibility test, of course, always. But when these anti-wear additives are added to your system, they will work as normal anti-wear additives, and they will increase the anti-wear capacity of your oil. Anti-wear additives are surface active chemistry. They provide a small layer of protection on the surface of the metal to decrease the friction coefficient, or to make sure that the metal molecules are not chipping away at each other. That's how these additives work. And we simply increase the amount of these additives into your system.
Okay, fantastic. And then maybe two last questions due to the time limitation, Lars.
Sure.
So first one, there is some customer asking about he have a problem with a premature engine lifetime. So the environment of that engine in underground, that there are dusty area due to blasting effect. So he replaced the air cleaner in 2 days. So what should I do in engine oil so the lifetime of engine meet the target?
Sorry, I did not fully get the question. So there was a dusty environment because of, or maybe, sorry, can you repeat it?
I believe he working in a mining industry and in underground area. So it will be like a very dusty area. So he asking about the engine lifetime. Seems the engine lifetime lower than should be.
Yeah.
Don't meet the target. So what should I do in engine oil?
Okay, engine oil. I see. Yeah, I understand the question, but unfortunately, we have not had any experience yet with ΔECON and engine oil. We would love to try it, so maybe we can contact you for starting a trial to see if it helps in that area. But for now, we have no experience with ΔECON and engine oil. In this situation, it's a very tricky and difficult situation. Probably a regular oil filter change is all you can do, but of course that will add cost as well. Or maybe there are specialized filter systems that you can use on the engine. But in terms of dosing something into the engine to prevent issues, we have no experience with that, unfortunately.
Okay, then. So we still have an open opportunity to have experience about the engine oil. Then. Okay, and then maybe last question. Is there any limitation of existing bed oil condition that still can apply of ΔECON?
Yes, there would be indeed. So normally when we look at an oil, we evaluate whether it's still possible to treat it, of course. So when, for example, aspects such as viscosity are off spec, the oil is already too far gone. You would not want to do anything anymore because it's not going to help you. Same goes for example, TAN, acidity levels of the oil. If they are too much degraded, then we have to discard the oil. If there's too much contamination and we cannot take out a lot of wear metals or whatever is contaminating the oil, beyond a certain point, we can also say, no, sorry, we can no longer treat this oil. But in some cases, we can use ΔECON, which is a major benefit as well, for a short amount of time. So let's say we conclude that the oil is beyond saving, you cannot use it anymore, but we can still put in, let's say, 5% of ΔECON, because it will clean up your system and it will remove all the residual varnish that this oil has been creating. And then when you change the oil, it will also remove this it will also remove these deposits from your system. So this means you have much less work in cleaning your system, and you don't have to do a chemical flush of your system before you dose in the new oil. And because the new oil then comes into a clean system, it will also last longer because it does not have to deal with already present contaminants. So it will have a much easier and longer life to begin with. So in many cases, we can still do something to help you clean up the system, even when the oil is supposed to be changed. But in some cases, which are very rare, it is so severe that we cannot do anything anymore. So it really depends on the oil condition.
Okay, very great. Thank you, fantastic. Really appreciate Lars, and we are sorry there are some questions still not answered yet, but we can do it privately. Yes. And then send the question, the email, and answer via email. Yeah.
Yes, please send them over. I'll be happy to look into it and answer all your questions. Yeah.
Okay, so I will resume in bahasa, Lars.
Great, thank you very much, everybody. Appreciate it.
So jadi untuk resume pada webinar hari ini, yang pertama adalah ada informasi terkait dengan 𝗬𝗵𝗶𝘀𝗁 pada gas turbine user group ya. Jadi failure itu mencapai 40%, isu terkait mechanical issue dan bahkan bisa dihindari. Kemudian varnish ini bisa terjadi pada berbagai sektor industri seperti power plant, oil and gas, mining, chemicals, dan industrial gases. Fluitec sendiri pada dasarnya mempunyai solusi. Jadi jika ada troubleshooting maupun harapannya bisa mengextend oil life. Yang pertama solusinya adalah terkait Solvancer tadi atau dikon, baik ada dikon EO, dikon AW ya, anti wear. Terus kemudian solusi yang kedua adalah menggunakan metode filtration varnish removal unit. Metodenya adalah ESP. Ya, I think we already finished the session at webinar. Thank you very much, Lars, and all participants to attend this webinar. Hopefully, we can have a joint webinar again in some times to sharing some updates and sharing some maybe new technology with us in here. Thank you very much.
Thank you, everybody. Terima kasih. Take care.
Oke, terima kasih semuanya. Saya akhiri. Assalamualaikum warahmatullahi wabarakatuh.